Thank you. So today I'm going to talk about a European initiative in support of the Green Deal and part of the Digital Europe program, which is called Destination Earth. Next slide, please. And I will give this talk on behalf of Peter Bauer, who couldn't be here today and who is leading these efforts at ECMWF. So what is Destination Earth? Destination Earth is an initiative which aims to develop a highly accurate digital replica of the Earth, or a digital twin, to monitor and simulate natural and human activity, and to develop and test scenarios for a more sustainable development of the European Green Deal initiatives, and basically for improving our capability to predict and monitor the Earth and how it changes in the future, and saving lives and avoiding socio-economic damage. So Destination Earth will be implemented on behalf of the European Commission. It should start soon. It will be taking place over several phases. The first of which is of 30 months. It will start soon. It will be implemented on behalf of the European Commission by the European Space Agency, ESA, ECMWF, the European Center for Medium Range Weather Forecast, where I'm working, and EUMETSAT, the European Meteorological Satellite Agency. And each of these have different roles, and I'll come back to that on the next slide. And the idea is really that in this first phase, the first digital twins or replicas of the Earth will be start to be done as prototypes, and then in later phases this will be embedded in a platform through which the users can interact with these replicas of the Earth and can inform policy making or different sectors. And in the third phase, basically the different digital twins will be merged into one complex replica of the Earth system. Next slide, please. So what will be, so the role of the three entities will be that ECMWF will be responsible for delivering a digital twin engine with an infrastructure, basically, which allows to run this highly sophisticated replicas of the Earth, which will be constructed by merging, fusioning in an optimal way observations and simulations in a much more advanced way than what we are doing today, for example, in weather prediction and climate prediction. And it will also be responsible for delivering the first two twins, which build really on advances in numerical weather prediction science, on technology, and on the scalability of these models. So what will be the two twins? The first twin will be a so-called weather-induced and geophysical extreme twin, which really will allow to enhance our capabilities to monitor, assess, and predict environmental extremes based on a merge of simulations and observations at much more higher spatial resolution than what we are able to deliver today, allowing to inform, really give inform decision support decision making at continental, country, coastline, and city scales in response to meteorological, hydrological, or air quality extremes. The second twin will be a climate twin on climate change adaptation, which again will be based on very high resolution simulations which will inform climate change adaptation policies and mitigation scenarios on multi-decadal timescales, aiming really at breakthroughs at the level of reliability at a regional and national level compared to the capabilities existing today. These twins will be embedded, they will provide data, they will have input and output data, which will be stored in called data lakes. This will be the responsibility of EUMETSAT to take care of all the data related to the twins. And the European Space Agency will construct what we call the core platform, which will embed these twins and through which users will have access to the twins and can interact with them and with the data that they are providing. And Destination Earth is really working in partnership with many other initiatives. It's not something on its own, but it's really building on advances in national and existing national and European efforts, and it will allow to further develop these efforts like the National Met Services or in those are done by the Copernicus services. There is really a complementarity between Destination Earth, the Copernicus services, existing national efforts to enhance our predictability, to enhance our prediction capabilities in Europe and beyond, and also in because I'm going to come at this in a second. Next slide, please. So how will these twins run, or these replicas, high accurate replicas of the Earth run? Some will be in continuous mode, so basically a bit like weather forecast that you run on a regular basis. These simulations. Some will be event or user driven. For example, you can imagine zooming in, for example, in the Arctic, if there is an event of interest like a polar low coming over Norway, you can imagine zooming in at much more higher resolution with impact models attached to the simulation, so that you can really better inform decision at level. Next slide, please. What are the breakthroughs? How Destination Earth complements the existing efforts? What are the breakthroughs that are expected? There are three main breakthroughs. First one, to the had huge advances recently in extreme scale computing and data handling, that we can really do much more realistic simulations through a better combination of much higher resolution simulations than what we have today, and much more observations, and blending this in an optimal way. So the computing time, the computing facilities now allow to do this at resolutions which are not possible until recently. It also wants to help integrating better the policies in the workflow, basically co-designing the digital twins in partnership with application sectors like energy, food, or water, and really through this better co-design to improve the prediction capabilities and better serve users, not only in the framework of Destination Earth, but also in other initiatives like the Copernicus operational services, for example. Finally, it wants to enhance capabilities of open and interactive access to data, software, and workflows, and to allow non-expert access and intervention to this data. Next slide, please. Now, coming to the Arctic, what is I mean, in the Arctic, well, no, there are some open questions. There are causes and effects and interactions between the poles and the lower latitude. We know that what happens in the Arctic doesn't stay in the Arctic, and similarly, we know that what happened in the mid latitudes can strongly affect the Arctic. So it's really important to develop a system. Earth system prediction capabilities, which allow us to develop capabilities which are can tell us things about tipping points, for example, to prevent us for surprises. When will the ice completely disappear? What will happen then? What will be the impact on local communities? It's really important as well to be able to better predict weather events, severe weather events, but also how in our of how, for example, that's what you see here on the small picture on the left, is how the same event can unfold in a very cold air plunging from the Arctic towards the mid. How will that in a warmer world in 2050, for example? So how and why the twins would allow us to be prepared for this change in our weather and climate? Next slide, please. First of all, because they really build on unprecedented simulation capabilities, which are fostered also by these advances in computing power. For example, you can see here a movie where you can see the sea ice from a hyper resolution model from the Alfred Wegener Institute called FESM 2 1 kilometer. You can see how realistic this looks, how the ice changes. Next slide. The twins also build on unprecedented observation capabilities. We have more and more observations. You probably are all aware of this vessel, which was a year to explore the Arctic weather and how it changes through the year. The expedition called Mosaic. There are many other efforts. There are so many efforts trying to fill the gaps by combining field campaigns, buoys, balloons, sail drones, etc., to better describe the Arctic climate. And what the digital to do will allow us the capability to optimally blend these very high resolution simulations with these much better observations in an optimal way. At very high spatial resolution, so that we can really give informed information at very local. Next slide, please. The digital twins also build on unprecedented digital technologies. I already hinted to this. There are advances in what we call the digital continuum, the HPC, cloud, data analytics, big data, Internet of Things, smart sensors. There are so many advances in this area. Also challenges, basically. So these advances allow us to do these higher resolution simulations and blend these observations and apply novel techniques like machine learning, improve the output of the simulation. But they're also because we have to be able to use these computers, the architectures of which are not exactly as they were until recently. So there is a lot of effort going on what we call the scalability efforts to prepare numerical codes for running on the simulations in an optimal way, so that we can take make the most of this digital computing continuum advances. Next slide, please. So building on these different advances, the digital twins will lead to unprecedented prediction capabilities due to the much more advanced way of blending observations and simulations, especially this very high resolution, but also the co-design effect with the users, knowing what they are interested in and putting that in the simulations. And hopefully they will allow to better predict both events, but also how these events, for example, will change in a warmer climate, like the jet stream look, how it will drive an extreme event in the future. Next slide, please. So digital twins, in summary, are highly relevant over the poles because climate amplification is in the polar regions, and there is a likelihood that there are tipping points when things will over and the climate will change in a very rapid way. There are many unknown processes and links with the lower latitudes, so we have to be prepared of how the weather and climate will change in the future in the Arctic. We need much more enhanced models and observations, and these are enabled really by the much enhanced digital technologies. And that the scenarios will really contribute to these efforts to improve our prediction capabilities from days to decades, alongside the other existing efforts over the next few years. So hopefully, next slide, please. In a few years, we'll really to arrive at the digital twin of the Earth system. And what you can see here, it's a very nice image from well, you can see the moon basically from one of the Apollo missions. On the on the left, and then on the right you can see how it was simulated from the ECMWF forecast today. It can become, the point is that the Destination Earth will contribute to these ongoing efforts in the community to make these two images look even closer and to really mimic the Earth's unprecedented level of detail and fidelity. And that's what all I had today. Thank you very much.
Digital twins, and we do have a couple of questions. The first question is, how are digital twins different from climate models?
So the difference would be it's based on the same principles. It's the same generation. I mean, it's the same numerical modeling. But what the digital twin will do is do this at much higher resolution. For example, the climate simulations today are at scales with grid box sizes of about 100 kilometers. The idea is that digital twins will be based in the future on kilometer scale. So basically, simulating the slide that with meshes of the size used, for example, today in regional weather forecasts, where the size of the box is of a few kilometers only, and but also use observations in a better way to constrain the climate models, similarly to what is done today in numerical weather prediction for weather forecasts. And also really to prepare these models to better inform impact sectors, like embed applications within the climate model itself in this high definition, high resolution climate model.
Thank you, Irina. We have extra more question. Do you think the phrase...
Alexander.
Yeah. Okay.
May I continue? Thanks for very nice presentation. Here's Markku Kulmala speaking. Very nice presentation, and we are actually during this process also here in University of Helsinki, Heikki Järvinen and myself, we have also been somehow part of this development, and it's very good that it's proceeding pretty well. My question is that how do you see, Irina, the need of different ground-based data, which we start to have huge amounts to develop these digital twins in different ways? I mean that in my point of view, we need multi-scale models, very high resolution models, we need satellite data, we need ground-based remote data, and different other ground-based data, both weather, air quality, climate, ecosystem point of view. How do you see it?
I totally agree with you. That's when I said that the twins will try to use not only much more high resolution satellite data, but also novel types of data, and ground-based data. The more data we have, obviously, the better to constrain the simulations, and ground-based data is part of it, but also novel types of data like Internet of Things from phones. So it's really help us prepare the capabilities, the technological capabilities to ingest this data in the prediction systems we already have. So I really see that the advantage, one of the big advantages of Destination Earth, which is in the framework of the Digital Europe program, is to really help us do add-ons on the systems we already have to expand their power in different ways, both in the simulation direction through resolutions or better processes, but also observations with more observations, and of course the more observations we can, the better it is.
Thank you. So we have extra more questions. Can we continue with questions? Yeah. Okay, there is another question. Do you think the phrase digital twin might be dangerous, since it perhaps implies a perfect model, which we know cannot exist?
Yes, you cannot exactly simulate the Earth as it is. It's like the human body, right? You can't really. But what we hope is that it will be the most accurately, or it will be a much more accurate replica of the Earth than what we can deliver today. So in that sense, the digital twin is not a new concept. It's a concept which is used actually quite a lot in industry. And there are, if you have a look, there are digital twins of everything. There can be a twin of a wind turbine. There can be a digital twin of a sort of engine. And so what digital really means is giving a boost in the capabilities we have to reproduce what happens on the Earth. Of course, there is not a perfect model, and there are no perfect observations. And even if you do the data assimilation possible, we can never exactly mimic what we hope. But in the meantime, there have been tremendous advances in numerical weather prediction, and I think we all know that we can foresee what happens a few days with a quite high degree of accuracy. So building on that, really Destination Earth, what it aims to do is to help us boost our prediction capabilities in Europe by investing in these different areas which are underpinned by the technology advances, which are much higher resolution, much more use of observations and of higher resolution observations.
Thank you. We have more questions. What are the efforts to exploit these huge new data sets, and how many people work on this model and its maintenance?
So there will be not one model. There will be different systems used for the digital twins, and there will. It's a distributed effort. As I said, an effort alone. So it's an effort in partnership with what's going already at numerical weather, as ECMWF, other centers in Europe, and with Copernicus services, for example. So it's hard to give a number, but there will be, and I can do a little bit of advertisement because you will see it today, there will be a number of opportunities, including at ECMWF in the framework of Destination Earth. You should, or later today or tomorrow on the ECMWF website, quite a number of vacancies in the framework of Destination Earth to work on these different aspects. There will be over 30 positions at ECMWF, but there will be more at partners across Europe in the coming months and the coming years.
Thank you. There are extra more questions. So is some Destin-E digital twin concentrating on atmospheric composition as well?
So again, as part of these efforts it will be to the different people who are doing different aspects of the digital twins. As I said, there will be not only one twin, there will be different consultants doing different part of the twins. But one thing what Destination Earth is also aiming to do is to have also bringing this high resolution also in impact sectors, and also tailoring the output of the models for impact sectors like air quality, for example. So yes, in short, atmospheric composition, hydrology can be part of the twins as well. Of course, and also to integrate this called before, what we are calling sometimes impact models, to better integrate them in the Earth system model. So that's what Destination Earth is also trying to do, to try, again, in complementarity with all the other services, is to really go away from this cascade of Earth system feed something to the impact model, example, the air quality, but really have this embedded in one single prediction system, coupled in two ways. So that's Destination Earth is also supporting efforts in that area in complementarity with all the other efforts at the moment.
Thank you. So we need to continue with our program. All